Part of the objective of having these presentations, as you may have noticed, is also to present to you best practices that a lot of your fellow peers in other industry in the state and educational institutions, for that matter, are taking part in, are taking advantage of. So hopefully it can spur some new ideas in your own facilities and what type of actions and projects you can undertake. Up next, we have another team presentation from Toyota, Mississippi. The three presenters are Linda Tucker, Phillip Williams, and Mark Hildenbrand. Linda has a Master's of Science in Industrial Technology from Mississippi State University. Linda has worked in various fields throughout her 12-year career, including manufacturing and refurbishment of helicopters, manufacturing of advanced unmanned systems and aerospace vehicles, and various manufacturing of ballistic and blast protected vehicles. She has a career at Toyota since 2012, and her area of responsibility is the body weld department. She is also a current warrant officer in the Mississippi Army National Guard in the Jackson unit. Phillip Williams has an industrial and instrumentation technology background. He spent the beginning of his career in construction industry building and commissioning chemical manufacturing facilities for various international companies, which led to his working at BASF for almost 15 years. He began his career at Toyota in 2007, where he was hired as the first team member for the Mississippi project, and currently he is the facilities mechanical engineering specialist, with main responsibilities being for all of the utility, equipment management, site infrastructure, and all of the site project management and support. Mark has a BS in mechanical engineering from Mississippi State University. He has worked in the manufacturing segments throughout his 30-year career, including textiles, aerospace, chemical, and HVAC industries. And now at Toyota, since at 2001, he's in the paint specialist area. So please welcome the Toyota team. And after this presentation, we will be breaking out of this room and going to the next room over for the award ceremony as well as the buffet. So hang tight.
Thank you. Good morning, my name is Linda Tucker. I'm a body weld production engineer specialist there at Toyota, Mississippi. I've been there since 2012. I would like to thank Mr. Chris Messimer for Mississippi Department of Environmental Quality for giving us the opportunity to talk with you today here at the 2016 MDEQ workshop. Speaking at this event gives Toyota the opportunity to talk with you about its commitment to the environment. To get started, we will look at our North American operations, look at what is going on at our Mississippi plant, and then review our continuous improvement projects for waste, energy, water, implementations in our facility. By the numbers, we have 10 plants in the U.S., we have created 365,000 jobs, and we have been operating in the U.S. for 58 years. With a full investment of $21.2 billion. And as of today, more than 1.3 million vehicles have been produced in the U.S. with 9 different models, and the most popular being the Camry and the Corolla. Now let's talk about Mississippi. As you may well know, the start of the production in the Blue Springs facility was the fall of 2011. This October, we will be celebrating our 5th year anniversary. By the numbers, 170,000 Corollas are produced annually with $961 million total investment since 2011, and Toyota Mississippi has donated 10 training vehicles to local schools. Toyota Mississippi is one of 4 global sustainable plants. Toyota Mississippi strives to be the #1 in North America in environmental performance. Along with our business investment and commitment to safety and diversity, we are dedicated to improve the lives of our team members, enhancing the quality of our life for our customers, and tackling the challenging issues that exist in our communities where we operate. As an example, Toyota has committed $250,000 over 5 years for the investment in the Tombigbee State Park. Toyota Mississippi has donated 5,000 volunteer hours with $500,000 to to area nonprofits. Now we will go into our technical presentations that will cover the continuous improvements at Toyota, Mississippi. I'm going to start the presentation with our waste Kaizen for respooling. Then I'll give it over to Phillip for our energy reduction project, and then Mark will finish us off with our water reduction projects. If you could, just save your questions towards the end of the interview, and the end of the presentations, and then we'll be more than happy to answer your questions. Body Weld Shop has a total of 9 Hobart MIG drums. We have 9 in our underbody line, and we have 4 in our main body line. Maintenance team members must change the drums when the MIG wire gets to a certain level so that they don't disrupt production, and those drums are then sent to be recycled along with the cardboard and the MIG wire that's in there. Disrupting production is approximately 15 to 20 minutes of our maintenance downtime for the change out of these drums. Body Weld, Kaizen, and offline repair shops currently purchase 7 MIG wire spools per month for offline repair and Kaizen projects that we do in our Body Weld shop. Each purchased spool by our Kaizen shop is $175 each. So what we did, we created several Kaizens for our maintenance team members so that they would understand when the MIG wire was at their certain level. We implemented an indicator light. We implemented a proc switch. So the proc switch, once the drum is moved out of location, it will trigger the light. Once the drum level of MIG wire goes down to a certain level, it will also trigger the light to come on as well. The top of the drum is normally just a complete cardboard top. What we did is we cut out the top and gave it a Lexan clear top so that maintenance could visually check inside. Also added a wire wizard guide to prevent from most of the burr and the tangles that was happening with some of the MIG drums. And we also implemented a quick release for maintenance for quicker change outs for their so that they wouldn't disrupt production as much. Team members still have to do their daily visual checks, but however, with all of these extra Kaizens, it's helped maintenance go a little bit further. So in trying to understand exactly what maintenance was going through as far as their disrupting production and us recycling so much copper wire, saw a need to implement a respooler. So this is a design that I worked with the Kaizen team. They built it for me, but what I did is I created, basically it's air operated. They can place the MIG drum inside, send it up. All they have to have is a 19 millimeter wrench, take out the retainer and its bolt, feed the wire through, insert the retainer and cap, close the door. We always want to close the door for the safety of our team members, and they flip the switch, and this respools the excess wire that is being left in the drums. Currently, what is normally left in the drum is about 33 pounds of MIG wire. So in saying that, since the Kaizen, I was able to respool the drums, I was able to get the Kaizen and offline team respooled wire, and there was no need for the Kaizen team to purchase this wire. And as I said earlier, it's $175 per spool. So roughly about 7 spools per month is what Kaizen was spending on these. So it was $1,225 per month savings that I was doing. So a yearly savings was $14,700 for just the Kaizen and offline team. As far as the waste, because it was 33 pounds per drum of waste, that equaled 3,396 pounds, which in total that would equal up to 3 complete full drums that they were throwing away and recycling. I also implemented work instructions and PPE requirements for them to be able to utilize the respooler. Now I will turn it over to Phillip for him to go into our compressed air Kaizen.
Thank you, Linda. My name is Phillip Williams. What we have with the compressed air system, look at this more as a system than just about compressed air, because this is, when you hear the word Kaizen, please understand that that doesn't mean something is broken and you went and fixed it. It is about continuous improvement. You don't know that you have a problem until you go and collect data. Look at your data, analyze it from the first slide with MDEQ, talking about the graphs. Sometimes when you collect a lot of numbers, until you put it in a graph form, you really can't visualize what's happening with the system. So please keep that in mind, and some of the questions that I ask myself when I go and seek Kaizen opportunities can be applied to water systems, gas systems, any kind of system that you operate and maintain. So we had a control system at our TMS facility. It was local control, it was web-based, but it didn't allow you to actually collect any data. You could view data, you couldn't store data, could not even remote stop the piece of machinery or any kind of programming. So it required team members to visually go to the piece of equipment, handwrite, log, collect data. This really didn't provide us with much historical or data collection whenever we had a problem. Very difficult to go back and trend to see what things were happening and taking place and be proactive to try to prevent issues. So we wanted to make that better and operate more for the ability of the plant to manufacture vehicles. And please note, this was working. This was not necessarily a problem. We were making vehicles, we weren't having any issues. So that kind of has the Kaizen mindset of improving. So after the Kaizen, we looked at installing, we actually designed our own custom program and put in place after talking to different manufacturers. Really didn't have what we wanted, so we built it ourselves. Now I have a remote control capability. It's on our intranet system, so from any PC in the building, I can look at the compressed air system, I can turn things on and off. The data goes into a server based in our IS department, so it's every data point in the machine is going to the server. I can pull up and trend, look at historical data. That also provides me with the ability to put alarm points and give me warnings, so when things are happening on a compressed air system, I see it before it's happening and be proactive. And it allowed us the ability to start understanding the efficiencies and how we were using the system. So these are some of the questions that you can apply to systems when you're trying to find issues or make improvements. How much of a utility am I producing? In our case, it was compressed air. How much compressed air is being delivered to the customer? What does the customer actually need? And which machines, if you have multiple pieces of equipment with different efficiencies, are best served to utilize those at different times? So once we got our system in place, you could actually see that I started looking at the weekly usage of a compressed air system. Two distinct things really spoke out on the chart. And with a lot of numbers in place, it didn't stand out as much until you graphed it. And you could distinctly see on the weekends, we had a significant reduction in consumption, or what we needed to produce for the building, what was being used. The second opportunity is when we broke it down to a daily standpoint. We operate on 2 production shifts with space in between to allow for maintenance and overtime activities. Again, 2 distinct opportunities stand out. So with the new control system in place, we're actually able to go in and build a schedule to turn the machines on and off and actually operate the most efficient machine when it needed to be happening in place. So we're looking at what needs to be delivered, when we need to deliver it, and by what means we're going to use to deliver that to provide the best return for Toyota. So you can see on the weekends, we developed a schedule that actually shuts the large machines off, uses a smaller centrifugal or variable speed machine to deliver the lower demands. Same thing between shifts. Instead of running one machine, large machines continuously 24/7, look at your peaks and valleys, decide if you can use a smaller piece of equipment at that time and utilize that. Match the load with the most efficient machine, program it. The custom program that we built is a system that kind of thinks for itself. It looks at what's happening. Redundancies are built in the event of failures to start other pieces of equipment. What were our results from this? Almost 500,000 kilowatt hours reduction per year, 17,000 MMBTU, an annual cost reduction of almost $40,000, in return a payback of less than a year, half a year. So ask why. When you're looking at your systems, we've heard several different people speak and make references to go to your facilities on the weekend when no one's there, your office when no one's there, and just stop and listen. What's running? Ask why it's running. We heard talk about HVACs and thermostats and control systems. Ask why your temperature is what it is. Ask, what rooms are occupied, what needs to be cooling, what doesn't need to be cooling. We heard reference of VFDs. VFDs are an incredible reference of saving. If you have a manual valve in a water process or some type of fluid process that you're controlling flow with, a VFD installation could save you up to 80% energy usage. So ask why. Don't let the abnormal become normal. Thank you. Turn it over to Mark Hildenbrand now.
All right, thanks, Phillip. Guess I'm the last one before lunch, so we'll keep it going. Along with energy and waste reduction, we also have water reduction, another one of our significant aspects that we really want to concentrate on. So one project we had was involving RO water. RO water is what we use for painting. It's similar to DI water. It's very pure, very low conductivity. We have to make RO water from just city water, non-potable. So this is kind of a simple diagram of just how an RO system set up. We take city water into a large tank. We currently run 200 gallons per minute non-potable into this RO system. And then from that, we generate 150 gallons of RO water and 50 gallons of waste. Basically, the water just feeds through the system, and we use the RO water, send it to the painting operations. 50 gallons of waste actually goes to wastewater treatment. So there's an opportunity right there. How can we improve our waste? 200 gallons in, 150 out, 50 to waste. Those are the key numbers. If we look at improved system, we added in a secondary RO system. Basically, this system here is actually takes the waste itself and runs it through a second system. It's a smaller system, utilizes a lot less floor space, a lot less energy. And what this RO system, the secondary RO system, we call it a concentrated recovery system. It basically takes all the waste, splits it out, and sends 25 gallons of that back to the city water tank. Very simple concept. You just run it through twice. So now our waste is cut in half. So now, instead of using 200 gallons to generate 150 gallons of RO, we use 175. So we're still getting our 150, only 25 gallons of waste. What does that mean in total in water savings? Okay, if you look at that on a chart, just taking a few months before we put in the change, July through January this past year, we were averaging around 208 gallons per vehicle. That's RO water used per vehicle. That includes all the painting, cleaning, E-code, everything. We put this system in February of this year, in the middle of the month, and immediately saw savings. And then in March, this last month, when we had a full month of savings, we were almost 60 gallons per vehicle saved, just resulting from that 25 gallon a minute saving because of all the cleaning and everything. The big number, if you put that in annual savings, is over 10 million gallons a year, which is quite a significant amount, and allowed us to meet our internal company targets. The second project I had was in our pre-treatment system. This is a system that we use to clean the car bodies. It's the pre-treatment side is 11 stages. It's got rinses, degreasing chemicals, conditioner, phosphating, everything before we e-coat the vehicle. I've got a couple photos I'll show to give a better explanation after this, but typically before situation, we have water is added to a rinse station, sprays off the degreased chemical. Anytime the conveyor is operating, the nozzles are spraying. There was 42 nozzles surrounding the vehicle, kind of in a halo form, which basically rinsed everything off. But there was a lot of water there, up to 60 gallons a minute flow there. The flow was controlled by operators who just manually opened the valve. So they could open it too much or not enough, and the water would vary, and we just didn't have a good control of our water situation. Afterwards on this situation, we looked at the programming and we said we can put in some sensors, some switches, and some counters to determine when cars are actually passing this rinse station to only turn on the water when the cars are present. Whenever there's a void or just an empty section of chain, the nozzles would shut off. We looked at the nozzles themselves to change the type and also the quantity of nozzles to get to make sure we had good coverage, but yet not use as much water to do the same job. So we cut down to 24 nozzles and reduced that flow down to a maximum of 33 gallons, and that's with the valve open fully. So we took the operator control out of controlling how much water was sprayed on the car. So this project was one we did this past January, and we achieved around 15 gallons per vehicle on this one. And if you average that out over the course of the year, that's another 2.5 million gallons. So even small, simple projects like these can generate a lot of savings when you have a large quantity operation. We got over 12 million gallons just from these two projects. So here's a kind of a better look at what we're talking about. This is showing the car body as it is coming out of a tank. These are recirculation nozzles. This bank of nozzles here is the rinse halo that actually extends over the top, and on the other side there's 42 nozzle spots there. And then this would be the after operation with the car there. You can see basically the nozzles are off as the car comes up out of the tank, and then as the car comes on, we have certain nozzles that come on and get full coverage on the car, rinsing the car and keeping the body clean. But also we plugged some of the nozzles that we didn't need because there was excess in the halo. So we went down from 42 to 24, and basically just a very simple activity. Just shows our Toyota's always looking for continuous improvement, whether it be a complex compressor project or just something simple like just reducing nozzles. So that's basically it. And if you've got questions for any of us,
I have a quick question. How often do you get together with your other plants to discuss best practices?
That's something we do continuously. We benchmark each other, you'd say. We have all the plants in North America, Canada, Kentucky, whatever. And any time we do projects, we see what kind of projects they have similar. Benchmark that. We call that Yokoten. That's our word we use, and that. They also have databases associated with different Kaizens that we can go through each project that someone does. They put it in a Kaizen database that's available for everyone.
And that's worldwide now, or just
yes.
Do that in North America?
That's worldwide. We get information from Japan plants also. Yes.
Now, are your sustainability initiatives more internally driven, or they end up being policy driven at times?
It's both. We have directives from corporate as well as we have our own internal plant targets.
Well, thank you very much. Please give a hand.